As I was trying to cut off the twigs off of this Christmas tree with this pruner, I have a sad story here with this pruner which failed rather spectacularly while trying to cut through something barely thicker than a pencil. So in this video, I'll tell you more about this item and why it failed. Let's take a look at the damage. You can see the handles aren't pointing in the same direction because it's bent here. You can also see that the edge failed at about minute 1, second 2 into the cut. And you can kind of see that the curvature of this failed part matches one of the twigs on this Christmas tree. You can see it's buckling and bending spectacularly, so much so that the pruner doesn't close anymore. So what happened here? I got this pruner from the neighbor lady who found it really hard to use it. It looks very lightweight, but she just couldn't really cut through much anything with it, no matter how hard she tried. So why this failed has two reasons. Reason one is that it's made out of mild steel. Mild steel bends like this. It doesn't chip or break, it bends. It bends to infinity almost. It could bend. If I kept bending it, it will bend without breaking. You get the idea. Okay, so this is mild steel. It is made out of a sheet steel that has a thickness of about this much. Actually, when measured with a vernier caliper, this thickness is approximately 2.7 millimeters, or almost an eighth of an inch. Let's go with almost. The same applies to this half here. They are made out of the same sheet through an industrial process called stamping. So there's a sheet steel, and these shapes, these cutter shapes, are just like with a cookie cutter in the kitchen. These steel bits are stamped out of a large sheet steel. So stamping is not a problem. The fact that this is mild steel is a problem. So yes, the components are thin, they are light, and yes, they bend. Mild steel is not really hardenable. So you can grind it down to form an edge, but it's not going to hold the edge. Just for contrast, here is another tool that actually works. The difference isn't only that this is shiny and this is black. Look at the difference in the thickness of the metal that's being used. This part here is 7 millimeters thick versus this one 2.7. And this part here is a thinner metal. This is 5 millimeters here, and then again it's tapering to a cutting edge. Just like this is tapered. So just because they look similar, it doesn't mean that they perform anywhere close to being similar. Removing the twigs from the Christmas tree, this one, it's just impossible to even start because the edge failed, like I said, at minute 1, second 2. So it's made out of the wrong steel, mild steel. What's this one made out of? Probably medium carbon steel, which is hardenable, maybe high carbon steel. I really don't know, but it doesn't matter because this works. But why this works is it's made out of the right steel and made to the right dimensions. It has thickness to it that supports the twig being cut at the moment of cutting, whereas this one doesn't. It just buckles and folds over, and that's basically it. And this is made to a dimension that is not functional. It's just made to look like a pruner, whereas this one is manufactured to dimensions that actually work. The thickness of the metal in this supports the cutting edge coming down when you're trying to cut dry twigs, anything like this. So this actually works. I want to point out this has an indicated manufacturer and model number on it that makes it potentially traceable and could actually be researched and looked up. This one has no indication of who made it, where it was made. And one last note on manufacturing. Like I said, this was made by stamping, which is fine, but not for making an item that actually holds an edge. This was made by forging. Forging is made by two forging dies coming together and compressing the metal in between the two of them. If you look at the fine detail of the handle there, you can see how the forging halves came together there on both sides. It's pretty obvious, and then it was machined to give it an edge. So forging versus stamping, but that alone doesn't explain why this one works and this doesn't. So again, this is made out of the correct metal, wrong metal, correctly dimensioned, badly dimensioned, and manufactured accordingly, inexpensively with stamping, manufactured carefully with forging.